Hi, everybody, and welcome to today's program. My name is Tim Culverhouse, Editorial Director of Robotics 24/7, and I'm so excited that you could join us for today's discussion titled From Simulation to Reality, Advancing Robot Vision with NVIDIA Isaac Sim and RealSense D555. Today's program is sponsored by RealSense in collaboration with NVIDIA. And before we dive into today's details, let's just go over some housekeeping. First, if during today's presentation the slides aren't advancing, please hit the F5 key to refresh your browser window. Now, we will have a live Q&A at the end of today's presentation, and if you'd like to submit submit questions to our speakers, you can do so at any time via the red question box at the bottom of your window. Now, any questions that aren't addressed in our Q&A will potentially be answered following today's program. If you'd like to download a PDF of today's presentation and other supporting documents from our sponsor, RealSense, you can do so by clicking on the blue paperclip resources box. You can also find that at the bottom of your browser. Now let's get into today's presentation. The next generation of robot perception and simulation is here. We're about to dive into how developers can seamlessly integrate simulation, perception, and edge intelligence into robotic systems. We begin by taking a look at simulating RealSense perception systems within NVIDIA Isaac Sim, including techniques for modeling real-world sensor noise, lighting variations, and optical imperfections to achieve more realistic and robust virtual testing. Then we'll get an introduction to Holoscan Bridge, which is a groundbreaking feature built into D555 that brings NVIDIA's Holoscan Edge AI platform directly to RealSense devices, empowering real-time sensor fusion and AI-driven insights at the edge. And before our live Q&A, we'll learn more about the native raw streaming capabilities of RealSense's D555, enabling direct data flow into robotic projects for faster integration and deployment. Now, to do all this, I'd like to welcome our guests for today's program. Chris Matthieu is VP Developer Ecosystem at RealSense, and Vikas Sharma is Senior Product Manager at NVIDIA. Now, Chris and Vikas, thanks so much for joining me today and discussing robotic perception and simulation with RealSense D555 and NVIDIA Isaac Sim. Now, before I toss it to these guys, let's get our audience interacting already. Right now, we have a poll question that is about to show up on your screen. We'd like to ask your feedback. We'll use the responses we gather from this poll as we kickstart our Q&A at the end of the program. So the question for our viewers today, in your perception workflow, which area poses the greatest development challenge? Creating realistic simulated environments and data sets, efficiently streaming and synchronizing RGB-D or sensor data, or running perception and AI workloads effectively on edge devices? Now remember, you can submit this at any time, and Chris, Vikas, and myself will go over this at the start of our Q&A at the end of today's program. So without any further ado, I'm going to toss it over to Vikas Sharma of NVIDIA to begin today's program. Vikas, over to you.
Thank you, Tim. NVIDIA advocates a SIM-first approach to physical AI learning. Physical AI models, VLM, VLAs, they are trained mostly using synthetic data, and they are tested in an environment like Isaac Sim before they are actually deployed to the real hardware. And that's where sim to real gap actually comes into the picture. Having a high fidelity model of your cameras, your sensors, and your robot really help mitigate this sim to real gap. And that's what RealSense team has done. They have created a high fidelity model of their D555 camera, which should help eliminate the sim to real gap once this model is used to create the synthetic data, and that synthetic data is used for training of your physical AI, VLM, and VLA. I wanted to just take a second and go further into this slide. This slide shows what NVIDIA advocates. Basically, NVIDIA advocates having these 3 computers for solving this physical AI challenge. First is your DGX, which is a computer used for VLM, VLA training. And then there is OVX, which is used to create this simulation environment on which you apply you apply your actions and you get your observation back to DGX. And the third computer that everybody knows and loves is the Jetson AGX, which is our edge AI inference computer. Chris is going to show some demo of this noise model for D555 in coming slides. Over to you, Chris.
Hey, thanks, Vikas. Let me go to the next, there you go. So for those of you who've been in the metaverse world or have used Isaac Sim, you'll see or you'll notice that it's almost a perfect environment. And what I'm saying is that when the RealSense camera is in simulation, it looks at things like in this example here, it looks at things like on the top right, you see there's a ball here in this image, and the ball looks on the top right part of this set of video of images. The ball looks like a perfect sphere, right? Like in simulation. But if you look at it, the two left images, this is what that same ball looks like in the real world. So you can see there's like noise like around the ball, and like look at the depth map down below, like bottom left. You've got the green, which means it's close, and you've got some yellows and reds and whatnot. Those are all important characteristics of that ball. Not only like if you were to have a robot, reach out and grab it, it needs to understand like the surroundings of the ball, but also from a training perspective, in the real world, when it's inferencing, it's going to be looking more like if it's too perfect, it might not actually see the ball. So what we've been working with NVIDIA on is this concept of adding noise into the simulation to make it more realistic in simulation, to make it look more like real life. So this isn't quite out yet, so I'm giving you a preview or a teaser of what's coming. This is what our new simulation SDK is starting to look like. So the two images on the left of this are actual like images from the RealSense on the ball, but the one on the right is where we're starting to add the noise to the simulator. So the idea is you should go right from Isaac Sim into the real world scenario without missing a beat. You should go right to, I see noise in simulation, so now I know how to account for noise in the real world. And the real world, as we know, is messy. From things in your way, from dynamic environments, things changing. So the better you can get this in simulation, all working together, looking like the real world, you're going to have a much better experience when your robot gets unplugged from simulation and jacked into the real world. Vikas, do you have any more feedback on noise?
Yeah, so we apply. So this noise model was created in Isaac Sim. So basically, we take a perfect ground truth depth noise map, and we basically apply a Gaussian noise as a post-processing step. And the way it works is we actually sample the noise based on every scene, and based on the confidence interval. We apply that noise and we tune it in a way that it really matches your real sensor.
Yeah, awesome.
So thank you so much, guys. As we make our way through the first segment of today's program, just want to jump in again. A reminder for our audience: submit your questions for Chris and Vikas at any time. We'll have our live Q&A at the end of the program. And if you haven't filled out your poll question response yet, please do so. Now let's get into some Holoscan Bridge integration. And Vikas, I'm going to toss it back to you. And as you go through this next segment of the integration between NVIDIA and RealSense through Holoscan Bridge, a question that I have for you is, what sorts of problems does the Holoscan Sensor Bridge solve for developers that are working in this platform?
Sure. Let me go over with a brief introduction of Holoscan Sensor Bridge, and I will answer this question after I introduce the Holoscan Sensor Bridge, if that's okay.
Absolutely, please do.
Okay. So Holoscan Sensor Bridge is an Ethernet-based high bandwidth, low latency interface. It brings diverse set of sensor. It can bring diverse set of sensor data directly to GPU memory for further processing or for AI consumption. In this picture, on the right-hand side, you see the compute, which could be IGX or Jetson, and HoloScan Sensor Bridge is an IP which can be installed on a FPGA or can be ported on a SoC, which is the case with D555, where the RealSense team ported this HoloScan Sensor Bridge IP onto the Ethernet-based D555 camera, which made it now a HSB compatible camera. Chris is gonna go through the detail on this specific camera in subsequent slides, but I'll just carry on with the HoloScan Sensor Bridge introduction. So this IP basically has two planes. One is the data plane, and other is the control plane. And the data plane and the control plane has many ways to configure your sensors, and the data plane can handle a lot of different sensor interfaces. Once you have your sensor configured, the HoloScan Sensor Bridge will take care of the data handling. So once you configure your sensor, you will via the APIs of HoloScan Sensor Bridge, your data will reach the GPU direct to the GPU directly. So you don't have to basically do anything in terms of data handling. HoloScan Sensor Bridge has many benefit. It reduces driver development time significantly. It also has inbuilt time synchronization. So basically all the data that comes through various sensors, it can be timestamped and synchronized. Like I mentioned, you can also bring high bandwidth data with very low latency into the GPU memory. And Chris is going to show you how HoloScan Sensor Bridge is implemented on D555. Over to you, Chris.
Awesome. Thank you, Vikas. I tell you, the HoloScan is groundbreaking, earth-shattering. Like if you look at the robots today, a lot of the humanoids, they're kind of, I hate to say janky slow, but you kind of you watch them kind of keep moving closer and closer to pick up an item, and you just want to pick it up and hand it to them. Well, or in a safety environment where you've got AMR robots moving all over a warehouse facility with people walking quickly around them. This HoloScan technology gets all the sensor data from the RealSense camera directly into the GPU of the Jetson on board. So these robots can make mission critical decisions in milliseconds, and like a humanoid, more fluently, reach and grab the item it's trying to pick up, or from a safety perspective, stopping an AMR in its tracks or moving it, having it, twist a different way to avoid an obstacle instantaneously. So I love this HoloScan. We do have it running on a D457 GMSL camera, but I had to add a Lattice FPGA board to bridge that camera sensors into a switch that the Jetson was on. But the crazy news is this brand new D555 RealSense camera. It's got our latest ASIC on the camera, which I believe has got 5 TOPS of compute. So we've always done depth processing on the camera, but now it's got HoloScan built right into this D555 RealSense camera. So what that means is you can plug the power over Ethernet right into the camera, right into the switch, and stream all the sensor data right into the GPU. So when you look at this diagram, it's almost like replacing the left side and the middle with just this RealSense D555, just with the Ethernet stream going directly into the Jetson. Crazy fast, and let me prove it to you. I feel like a salesperson, but I think the camera does all the sales on its own. I have a video demo I did that shows HoloScan in action with the RealSense camera. So let me show you what it looks like. It's only a minute. Hey, Chris Matthieu from RealSense Inc. I want to show you something really, really cool. This D555 stereo depth camera, newest camera from RealSense, has built-in power over Ethernet, built-in ROS2 DDS streaming, and built-in NVIDIA holoscan support, meaning you can go right from the sensors to a Jetson GPU. If you look at this, how it's wired up here, I just have only one Ethernet cable plugged into my D555. So power over Ethernet, that is plugged into a power over Ethernet switch right here in the middle. And then my NVIDIA Jetson is plugged in with an Ethernet into that same switch. And if you look behind me, there's a depth map. I mean, look at this. This is so amazingly fast. This is right into the GPUs of the Jetson from the camera. RGB depth, IMU, this is truly amazing. How about that?
Well, thank you, video Chris. And a question also now for live Chris as we move our way into the next segment of today's program. Again, for our audience, we see some questions already coming in to Chris and Vikas. They're looking great. Please continue to do so. We've got plenty of time for that at the end of the program. And just once again, if you haven't filled out the response to the poll question we asked at the start of today's program, please do so. So you've touched on this a little bit already, Chris, in terms of ROS streaming with the D555, and you're about to go in depth in it. And just a question for you with it, how would you describe the difference from the legacy RealSense ROS driver with what we have now with D555?
Wow, that's a great question. So with the traditional RealSense cameras, you have to plug them into a machine that's running provided you're in a ROS environment. You have to install the RealSense SDK, and then you have to install LibSense ROS or RealSense ROS. And then what that does is they're basically drivers, if you will, that are basically converting the camera's data, like just any RealSense camera data, into ROS topics of the stream. With the D555 and the new ASIC, not only can we do holoscan in real time, but we can also do ROS2 DDS streaming directly from the camera. I've got another demo here in a second, but you can imagine you plug a power over Ethernet in, the camera lights up. Again, it doesn't have to be plugged into a host. It plugs into the network. Again, no LibRealSense required, no RealSense ROS drivers required. The camera lights up and starts streaming all the ROS topics from the camera onto the network. So you've got like the camera ID, like image raw or image depth, whatever the topics are, the IMU topics. You've got all of that streaming. So if you're a Jetson, the brain of the robot, you can just listen to this camera, that camera, the other camera, and you're getting all the ROS topics in real time without any, it's plug and play, without any configuration on this camera. Does that answer the question, Tim?
I think so. I think so. And I think we're about to go back to video, Chris, as well for another demo.
Yeah, let me show you. I'm really proud of this demo because when I saw it, our engineering team was saying, "Oh yeah, it's built in ROS." Until I saw it with my own eyes, I didn't believe the opportunity that this creates. So power over Ethernet with ROS2 streaming. Let me show you how that works. Hey, Chris Matthieu from RealSense. I want to show you something really, really cool about these brand new D555 power over Ethernet cameras. They've got built-in ROS to DDS. This kind of blew my mind the first time I saw it. So look right here. I don't have anything plugged into the camera. I've got a little NVIDIA machine here with ROS2 Humble on it. If I go here and I go ROS topic list. So that says, tell me all of the ROS topics listening on the network that are broadcasting. It's just got your basic parameter events and ROS out. That's what every ROS node comes with. But watch this. when I plug the power Ethernet into the camera, the RJ45, it's going to basically bring power to the camera. The camera's going to boot. You can see network activity already down here on the switch. I'm not sure if it's booted yet, but let's run that RS topic list again. Sure enough, look at that. So we went from just 2 topics to this whole suite of RealSense ROS2 topics. No computer, just ROS2 DDS publishing from the D555 RealSense camera. So it gets more cool than that. So you want to echo or watch the stream? Check this out. So I'm going to run ROS2 topic echo, and I'm going to give it the motion sensor, the IMUs of the camera. Check this out. Boom. XYZ IMUs, linear, angular. This is so cool. So ROS2 DDS built right into the D555 power Ethernet camera. How cool is that? How cool is that?
I was going to say, again, back from video, Chris, to reality. Follow up to that question for you, Chris, before we make our way into the Q&A segment. And, you know, as you and Vikas have kind of making our way through this journey from simulation to realism, native ROS streaming into the edge AI components that you guys have briefly touched on, I'm kind of curious now, you know, what's next for developers to try this stack themselves? What sorts of things do the developers in the real world, those that are watching along on today's program, thank you again for everybody for doing so, to get their hands on it and to try it and play around with this integration that you both have been discussing?
Vikas, did you want to start that off?
Yes. Sorry, my audio was dropping. Can you, Tim, can you please repeat the question?
Sure thing, of course. No, so what I was asking, and this is great that you both will chime in with it. We've seen this journey that you both described between simulation to this reality, making its way through native ROS streaming and the edge AI fusion. So, you know, what's next for developers to get their hands on this, try the stack themselves and kind of play around with all of these capabilities that we've seen in Isaac Sim and the Holoscan bridge integration with the RealSense D555?
Yeah, so, you know, as far as the noise model goes, so this noise model was released with Isaac Sim 5. So if you download the Isaac Sim 5 and if you look at the documentation, you can get the details of, you know, what parameters are exposed to mimic the noise in the you know, in the depth map. You know, that I think this is also a question being asked in the you know, in the Q&A, that, you know, this model, the depth noise model, is a generic model which can be used to mimic noise for any stereo camera. You know, RealSense team was the first one to take that model and build a high fidelity digital twin for D555. And as far as Holoscan sensor bridge is concerned, you know, any application where you have either a diverse set of sensors, or you have a high bandwidth a sensor requiring high bandwidth data transfer, you know, Holoscan sensor bridge with its you know, high bandwidth and low latency is the perfect way to you know, to address your use case. You know, Holoscan sensor bridge has been publicly released for a while. You know, we just released a latest revision for Holoscan sensor bridge. All the documentation and the user guide is available. And also, if you are looking for a native camera, you know, you can try setup with our partner Lattice or Microchip's FPGA, and you can bring in your MIPI or your GMSL camera. But if you want to try a native camera with Holoscan sensor bridge, then D555 would be a perfect candidate for that.
Yeah, and I would piggyback on that. You know, Isaac Sim is free, that whole ecosystem that Vikas was showing, and the 555 is under $500. The bang for the buck, you get so much performance out of this camera. It's really cool. I saw one more crazy fun thing, to kind of answer your question, Tim. I was at a conference about a month ago, and my challenge was to live code a follow me robot on the stage in 30 minutes. And I was like, this is either going to be spectacular, awesome, or it's going to be a spectacular fire flame throwing disaster. So I got up there, and what was cool is I had a tiny little $200 ROS robot I put together. All it had on it was ROS 2, plugged in this camera, and then I started vibe coding. The RealSense SDK is open source, PyRealSense 2, all of this stuff. I just said, hey, cursor, can you use the image raw stream of that's coming in on ROS of the 555, and can you just tell me, is there a person or not in the frame? And then if there's a person, I said, follow the person using ROS 2 twist commands. So I kid you not, like in 10 minutes, I had my follow me robot working, following me around on stage, because I didn't have to do any configuration. I plugged this camera in, told it was running ROS 2, and then I was using Quinn as a local LLM. And what Vikas was talking about earlier about physical AI or embodied AI, that's basically what I did in 10 minutes using just basic ROS. What do you see? Oh, and I told it too. I said, stay within 1 meter away from the person. And Cursor actually wrote this in such a way I didn't even expect it. If it was further than a meter, like much further than a meter, it was sending higher velocity twist commands. So my robot was basically running. And then as soon as it got close to me, it would either stop if it was a meter away, or it would start slowly, moving forward. And it even turned. Like, it blew my mind, like where all of this is going. Like all you need is ROS, all you need is a VLM or something like that. And I kind of did my own VLA, if you will, in with the mission. But it's amazing how fast all of this is going, and it's also amazing that the tools are out there. The tools are out there for enthusiasts or hobbyists, all the way up to industrial engineers to use and perfect their robotics platforms.
Awesome. Well, I appreciate everything that you guys have done in 30 minutes, less than even, going over all these integrations between what we're seeing with the D555 and NVIDIA Isaac Sim and the different simulation and perception capabilities that are going on with these machines and software. So thank you so much for that. And now we'll start making our way into the Q&A segment here with Chris and Vikas. And again, thank you to everybody for tuning into this program here, sponsored by RealSense in collaboration with NVIDIA, hosted by us at Robotics 24/7. So before we get into the Q&A, that poll question that we've been mentioning a couple different times, let's take a live look at the responses here. So again, the question, your perception workflow, which area poses the greatest development challenge? And it looks like the leader in the clubhouse was option A, creating realistic simulated environments and data sets. So guys, I know we're doing this live, so it's great that we have this question here, but either of you have any initial thoughts or feedback on the responses we gathered from this prompt?
I can, comment on the most popular choice. I think this, the creating realistic, simulated environment is somewhat of an art more than a science. You really need good assets to create a realistic environment in Isaac Sim. We do provide sim-ready assets, and we are continue to grow our library of sim-ready assets, which can be used, which can be used to create these realistic environments. When I say sim-ready, it's just not photorealistic, but it also has physical properties. It has a mass, it has the material, the right material to to reflect light and stuff like that. So we are working with many partners to create these sim-ready assets, which can be which can be used in Isaac Sim to create these real environments. So far, like typically what used to happen was that you need to hire a technical artist to create these sim-ready assets, which was very time-consuming and expensive. We are now creating these open source, set of sim-ready assets which can be used, in your environment. So we are starting off, I think, more with home and also with industrial setup. So what I'm trying to say is it's going to get easier, as we progress and as the need for sim first physical AI training grows.
I tell you, I'm impressed and humbled that the second item, the streaming and synchronizing RGBD and sensor data, is the least complicated on the list. Like that warms my heart knowing that our SDK and whatnot is making RGBD easy.
There we go. The enjoyment of live, I guess, TV, but live webinar programs here. So thank you guys for providing some context on this answer. And again, thank you to our audience for submitting all these things. So let's get into our audience Q&A. Lots of questions from those of you that are joining us today. So thank you so much. First one, I'm going to go over to you, Chris. I think this might be a quick one, but obviously please elaborate as you need to. Question is, which Jetson is needed for D555? Thor, or are we running in a different system?
So on my demos there, I was using Orin, AGX Orin, but it'll work on Thor as well. Maybe that's another question for Vikas. Like,
yeah.
Does HoloScan work on anything previous to Orin?
So, I would say the sweet spot for HoloScan sensor bridge is Thor, because Thor has this offloading engine which takes in the Ethernet packet and it kind of depacketize it without putting any load on the CPU. So the full glory of HSB can be seen on Thor, but it can work with Orin. But your CPU will be loaded when you depacketize these Ethernet packets, because Orin does not have this offload engine. So anything with ConnectX like IGX, HoloScan sensor bridge is a great fit. Is basically meant for anything with a offloading engine, which is like a ConnectX or a offload engine on Thor, which will basically make the CPU utilization to 0. Yeah.
You just guaranteed my reasoning on purchasing a new Thor for demo purposes. You've justified it. Thank you.
Yeah.
We've got two engineers here working the sales side of our conversation. So I hope everybody's getting enjoyment out of folks wearing multiple hats in today's conversation. But thank you guys so much for that one. Other questions coming in. Another one for you here, Chris. Which ROS 2 version were you running in the demos? And if you could potentially provide a little bit more context around that, please.
Yeah, so I use a number of different flavors of ROS. I mentioned Humble in there earlier. That's just because I happen to have, I was testing something else on Orin on Ubuntu 22 instead of 24, but I use Jazzy as well. It doesn't really matter regarding it has to be ROS 2, not ROS 1. Now, I think I saw that question in the comments, but the D555 camera, it's using DDS. So it's not a particular ROS flavor. It's using the messaging subsystem of ROS in general, ROS 2 in general. So whether you're on Humble or Jazzy or a newer version of ROS 2, you'll still be able to hear or listen to all of the ROS 2 DDS topics streaming from the D555 RealSense camera.
Gotcha. Thank you. Thanks as well for submitting that. We're still going with our Q&A, but just wanted to put up here a couple of QR codes for our viewers today. If you want to learn more about D555 or HoloScan Sensor Bridge, you've got some QR codes on your screen right now. Take a picture of. Now, if you don't get a chance to right now, two things. This webinar will be available on demand. Take a look at it at your viewing pleasure, and we will have a PDF copy of today's slides available for you as well following today's program. But if you'd like some more context on these hardware and software platforms that we're discussing today, got a couple of options right here on your screen. So back to the Q&A. I've got one now for you, Vikas, and it is, how many cameras can the Holoscan sensor bridge handle?
Yeah. So, this question, I hate to say it depends. We have tested 20 cameras, 4K cameras, sending data through Holoscan sensor bridge. But, it depends on your setup. We were using like a soft ISP. We had our own pipeline where, there was no bottleneck basically. But, it really depends. If you have a pipeline, you may have a bottleneck somewhere which may prevent you from, using that, that many cameras. But, Holoscan sensor bridge, most likely the bottleneck will be on your ISP side or some other side, but not on the Holoscan sensor bridge. So, we have validated 20 cameras, 24K cameras.
As the journalist and moderator in today's conversation, the "it depends" answer always sends up an antenna, the dreaded response from interview candidates. So thank you for providing some context on that one. Greatly appreciated. Question now for Chris. So this one is, will a version of RealSense's D555 with built-in PoE and ROS2 support be released in the future? Now, this question also adds the caveat of D555 is slightly too big for this question submittance needs. So looking for a smaller alternative with those features.
Wow. Well, unless we NDA your whole audience, I can't get real specific, but I can tell you the D555, I was blown away on the demand. Like we sold out. Like when we announced this camera, we sold out. Now we have more in stock. But the reason it's a little bit bigger than the traditional RealSense camera, well, for one, it is the longer range camera. It's a 6-meter camera, but the new ASIC in it, V5 of our Vision Cortex, is a little bit bigger, and the heat we were getting from the power Ethernet was a little bit much, so we had to put another heatsink in it. But this is version 1, so you can imagine this getting back down to the size of like our traditional 455 style cameras or GMSL style cameras, and I can almost assure you that you'll see other cameras, different ranges in this same technology footprint, like this new ASIC and capabilities. So I can just say, stay tuned.
A pitchman at his finest at work there. Right? No NDAs as part of your registrations today, everybody. So don't be too concerned about that. But thank you so much, Chris. Another one here that we got a couple different ways formatted from our audience. And Vikas, I'll toss this one to you first, and then Chris, I'd love your follow-up on it. But generally speaking, in terms of robots, I know you've both described humanoids. Obviously, that's the sexy topic when it comes to robots and these technologies. But I'm curious, what types of robots do you both think will benefit the most from this integration with Holoscan Bridge, with the D555, and everything that we've discussed today in simulation and perception capabilities?
I think any robot where either it's very hard to collect data from, and if you're training policies for novel skills, I think having a good high fidelity sensor model in simulation is essential. So anything where you need to train your physical AI model in simulation first, I think that would be like a perfect candidate for for the user of this D555's model, the simulation digital twin. And if your robot has like multiple cameras, IMUs, LiDAR, radar, anything, like temperature sensor, any kind of sensor. If you're trying to bring a lot of diverse sensor data into the GPU for your model training, and if some of your data is high bandwidth and you require like low latency response, then that would be like a perfect candidate for holoscan sensor bridge. And hence, if you're looking for one native complete package, then D555 is the camera to go with. And like Chris mentioned, hopefully the next rev of this camera will be smaller and will be more suited to the form factors, various form factors.
Yeah, I would say it's like peanut butter and chocolate. If the 555 and holoscan, I would also say that yes, AMRs, humanoids, even arms, like if they need the range on a particular arm. What else is, like, I talk about robots, I love robots, I turn into a kid when I talk about robots, but the power over Ethernet that it's running is 100 meters. It can go up to 100 meters long. So when I talk to other people, I mean, they're even using this like Google Analytics in the real world, like putting these, like at the storefronts or in their warehouse facilities and running, Cat 5 or 6 all the way, to the closet. And that works great on these cameras. But yeah, especially if you need instantaneous, reaction, it doesn't get faster than RealSense, Switch, Jetson, like Thor, like Vikas was saying, where you've got, I even saw on the website, don't hold me responsible. I think I saw on the website, it could be as fast as 17 milliseconds going from sensors to holoscan over Ethernet. So you're talking real fast capabilities.
Awesome. Thank you, guys. I love hearing the deployments, and the Google Analytics conversation certainly piqued my interest. That's what I'm in all the time with Robotics 24/7 and tracking the data with it. So great to hear. Only time for a couple more questions. Again, thank you so much for our audience. We've got a lot of them coming in. We're not going to get to all of them today. I apologize. There's a chance Chris and Vikas could answer them following today's conversation, but we'll do our best to crank through a couple more here before we make our way out for today's program. And Chris, one for you here. Could D555 be used, and this is an extension of the robotic application, used to replace LiDAR in some AMR applications?
I think there's always different use cases, different caveats, but I mean, I'm a huge fan in vision. Like humans have two eyes, the RealSense cameras have two eyes. Instead of SLAM, it's VSLAM, Vision SLAM. We're working with NVIDIA on some VSLAM technologies. If you're interested, we are looking for guinea pigs. I should throw that out here to this audience. If you're interested in either humanoid or AMR VSLAM capabilities with our cameras, hit us up. And if you qualify, if your use case looks interesting enough, maybe there's an opportunity to collaborate. But I'm bullish on vision. I think it is it is how we see, it is how robots need to see. And yes, I think you can. And actually, we've got some other cameras on the roadmap that we think will definitely rival, if not kill, some LiDAR implementations.
Oh, we're making headlines with today's conversation. Can't wait to. No, it's quite all right. Couple more rapid fire ones for you here, Chris, and then I think we will start making our way out here. So 2 technical questions related to the D555. Question 1, any plans to support Mac OS? And question 2, any weather or dust resistance capabilities on D555?
Okay, I love those questions. I'm a Mac user. I've been for a long time now. And a sneak peek, I don't need an NDA for this, but I saw our engineering team show me a Mac version of the LibRealSense SDK that had full, raw support, full PyRealSense support, and it ran on a Mac. So we used to support Mac back when it was Intel Macs, and I just got the secret code to try it out on my own. So if it passes the Chris Robot Wizard test, I can suspect that you'll be using RealSense on Mac here soon enough. The second question around weather, like dust and rain, outdoor use, the 555 as well as the D457 for GMSL, they're both IP65 rated, so they're not submersible, but they'll definitely handle like dust and weather. So yeah, that's another benefit we forgot to talk about. One more other kind of really kooky, crazy things to mention. I don't know if you can see it, but here's a close-up of the D555. Notice that these two side lenses are RGBs. They're not your typical IR depth sensors. So stay tuned for what else you can do with dual RGBs built into the hardware. So stay tuned for more fun demos.
Both of you talking like true pitchmen, and greatly appreciate it. But that is going to conclude today's presentation. Apologies again for our audience. Thank you for submitting so many fantastic questions for our speakers in today's thing, both before and during the presentation. Now the guys may potentially respond to some after the fact, including Chris and Vikas mentioning some guinea pig, potentials with RealSense and NVIDIA. So before I sign off, guys, I just want to say thank you both for joining us today. Really insightful conversation. Loved hearing more about what we have going on with RealSense and NVIDIA, and so glad that you guys could be here today. So thank you so much, Chris and Vikas.
Thank you, Tim. Thank you, Vikas.
And for our audience, well, thank you guys again. And now for our audience again, we're going to wrap up. A PDF copy of the presentation and other related content from our sponsor, RealSense, in collaboration with NVIDIA, can also be found in the resources box on your console. Now, at this time, if we ask you to please fill out a feedback survey that will open up on your browser. Thank you in advance for filling out this survey. Your participation allows us at Robotics 24/7 and Peerless Media to improve upon our future events. And once again, thank you so much for attending today's event, From Simulation to Reality, Advancing Robot Vision with NVIDIA Isaac Sim and RealSense D555. Thanks to our sponsor, RealSense, in collaboration with NVIDIA. And again, with Chris Matthieu, the VP of Developer Ecosystem at RealSense, and Vikas Sharma, the Senior Product Manager at NVIDIA. We're so glad you could join us today. You'll receive an email after today's program with instructions on how you can access this presentation on demand. So once again, Tim Culverhouse, Editorial Director of Robotics 24/7, signing off. Thank you again for tuning into today's webinar, and we hope you join us at our next program soon. Enjoy the rest of your Wednesday, everybody. Thanks so much. Bye-bye.